x cubed plus x squared is greater than or equal, or is less than or equal to 4x plus 4. For what values of x is that true? So again, let's set this equation on up to solve it for 0, because that will help us find the boundary points. Now I know earlier I didn't use equal here, I just kind of kept that same sign. But again, for our purposes at this point, we're just looking for its boundary points. We're looking for where it does equal to 0. And so if you want to use either notation, that's fine. However, when we go back and use our test points, we need to make sure we plug it into the inequality. But for our purposes right now, we're just looking for its boundary points. So how to solve this? Let's see if we can group it before we get into some of our sophisticated ways to solve a polynomial. Looks like that could be an x squared with an x plus a 1. I factor that out. These two terms I can factor out a -4. And I'm left with an x plus a 1. Yippee for me. So that's left with an x plus 1 times an x squared minus 4 equals 0. So fortunately, we were able to factor it by grouping. It can continue to factor, so I'll have an x plus a 1. This is a difference of 2 squares, so an x plus a 2 and x minus a 2. And that equals 0. This now provides for me all their boundary points. And again, I like putting 0 just kind of in the middle and some tick marks. I have boundary points at 1 or at -1 right here. So here's a boundary point. -2 is a boundary point. And +2 is a boundary point. So those are my boundary points. I don't know where the solutions are at yet, so I don't know which way the hard brackets will go. I do know that these points will be inclusive, so I will fill those in a second. So let's solve and do some test points. Let's do 0 since it's right in the middle. I love doing 0. So I would have 0 cubed plus 0 squared is less than or equal to 4 times 0 plus 4. 0 is less than or equal to 4. That is true. So I know then that this test point was 0. These sections in between are true. All right, I have 3 more sections it looks like. This test point over here, 1, 2, 3, let's try a 3. So 3 cubed is a 27. 3 cubed plus 3 squared, is that less than or equal to 4 times 3 plus a 4? 27 plus 9 is 36. 36 is less than or equal to 12 plus a 4. It doesn't look like it. It's 16. Or if I made a mistake, it wasn't a factor by 20. So that is not true. So I know that all these points over here are not true. These points, yes. All right, let's try this section in between here. And that's between the points 2 or -1 and -2. So we're going to have to try -3/2. So I have -3/2 cubed plus -3/2 squared. That's less than or equal to 4 times 3/2 plus a 4. All right, -3/2 cubed gives me a negative 27 2 times 8 plus -3/2 squared is a 9/4. Is that less than this? 4 times 3/2 or 4 3/2 gives me, yeah, it's a 4 times a 3/2. Gives me a 6 plus a 4, which makes a 10. And, oops, sorry, That was a negative 3 halves, wasn't it? Negative 3 halves there gives me a negative 6. So negative 6, so this gives me a negative 2. Glad I caught that mistake. I'm glad you guys caught that. And then from here, add those together, negative 27/8. Common denominators would make this an 18/8. Greater than or equal to negative 2. Negative 27 gives me, what is that, negative 9? Is negative 9/8 less than or equal to negative 2? Nope, that is not true. So the test point I chose right here is not true. So I would say that section would not be true. And the last test point to choose, 0, 1, 2, 3. Let's try a negative 3. So negative 3 cubed plus negative 3 squared. Is that less than or equal to 4 times negative 3 plus a 4? Again, just got to crank it out. That's negative 27 plus 9. Negative 12 plus a 4. Negative 27 plus a 9 is a negative 18. Is that less than or equal to 8? Is that true? And that is true. So that tells me then that all the points from here on out are true. And then to write my solution in graphical or in interval notation, or I have a graphical solution, to write that in interval notation would be negative infinity to that point, which was 0, 1, which was negative 2, inclusive on that, and, or I guess, or the solution is over here from negative 1, includes all the way over to 0, 1, 2, 2. So there's my solution set, represents that all these values within the intersection or with the union of those two intervals is a solution to this polynomial inequality. I hope it wasn't too difficult. The part was, it was just a little bit tedious at times, and just working through and making sure we don't mess up with the fractions and just trying to keep our work clear. But other than that, I hope you feel like, okay, it wasn't too difficult. I kind of get what's going on.